So it's an imaginary, yes. So it has an imaginary number in it.
There's a booty hole.
Okay, so this is the way the book sort of does the definition. It says that a complex number, they usually will call it Z for whatever reason in our textbook. So they say Z is equal to X plus YI. And that I is the imaginary part of the complex number. Okay? And so they're basically saying you go in and you plug in an X value, you plug in a Y value, and you have yourself a complex number. Like, you know, we could have 3 plus 4i. And that's an example of a complex number. Or you can have negatives, or you can have fractions. Have an example of a complex number. So you're basically just putting in a number for the X, putting in a number for the Y, and having that complex number. Right? So this is sort of what we talked about as a rectangular form. Okay, this is involving an X and a Y. So the first thing they want us to be able to do is they want us to be able to plot these complex numbers. So they give us this one as a starting place. And they ask us to plot it. Now, what you need to do first is you need to be able to look at that complex number, and you need to be able to identify what is the X value and what is the Y value. So the X value is the number that sits by itself. The Y value is the number that sits in front of the I. So the X value is what?
Square root 3.
Square root of 3.
And minus 1.
And the Y value is what?
Minus 1.
Minus 1. You need to take a sign with it, because remember that your general form had a plus, so you're really looking at a plus and negative I. Okay, and then you basically plot that just like you plot a regular point. They do make the stipulation, they say that your x-axis is going to be called the real axis, and the y-axis is now called the imaginary axis. So they're sort of changing the foundation there a little bit. It's not like an x-y axis like we had in algebra. But in terms of you plotting the point, it is exactly the same as it would be in algebra. Okay? So you've got your x value, you've got your y value. You may need a decimal for square root of 3. Square root of 3 is like what?
1.73.
So I'm going over 1.7 and
down
-1. Okay, so there's my point right there. Call it Z, and we're done with that part. Okay, so identify your X and your Y. Plot it just like you would normally plot. All right, okay with that? Okay, the second thing that they're going to want you to do is they're going to ask you to find what is called the magnitude of the complex number. Now, a couple of things about this. If they're talking about magnitude, they're going to write it this way. Okay, so kind of a set of brackets, or not brackets, what do we call it? Straight lines.
Is that absolute?
parallel.
It does not mean absolute value, okay, but it looks like an absolute value, but we're not talking about anything where an absolute value would come into play here.
Visual.
What it is, magnitude, is the distance from 0, 0 to the point. Now, I want you guys to think about this because I'm thinking we've already done this, right? I mean, haven't we already talked about something where we're talking about the distance from the origin to the point? R. Okay, do you guys remember that? That when we talked about R, we said R was the distance from the origin to the point.
Yeah.
And how did we find
said
R?
context. How do we find it?
Yeah.
Square. X squared plus B squared.
R squared equals X squared
Or
plus
Y squared.
Okay, now I want you to look. That's the R formula that we did before. I want you to look at this formula that they give you in the book for magnitude.
Just square root is difference.
Now, the notation on the left is different because we're talking about magnitude. They're not saying find the R, so I mean it makes sense that we wouldn't necessarily have an R in the formula. But what about the rest of it?
The same thing.
It's exactly the same
as
thing.
that.
It should be the same thing if I took the square root of both sides there. It is exactly the same formula, okay? So the formula that they're giving you is this. If you don't want to bother with memorizing a separate formula, then realize it's the same thing, okay? And do it the other way. It does not make any difference, okay? I'm going to actually go through it both ways just to show you in case you're still a little iffy about it being the same. So what's going in for the x?
0.
Square root of 3. And the y
Negative
we said
1.
was negative 1. So I square the square root of 3 and I get 3. And I square negative 1, I get 1.
Answer would be 2.
So it's going to be 2. Okay, and then look over here with the R formula, and just, you can write it down or not, but just look at it. It's going to be exactly the same thing. Plug the square root of 3 in, plug the negative 1 in. We come up with R squared is equal to 4. We take the square root, and we get 2. So exactly the same thing as finding the R. You guys all right with that? Okay. All right, and then the last thing that they're going to ask you to do is they're going to say to come in and write complex number in polar form. All right, which brings in this idea of polar coordinates as opposed to rectangular. Now, the format that they ask us to write our answer in looks like that. Okay, so if you're going to write for me a complex number in polar form, it needs to look like that. You can't just say R is this, theta is this, and be done with it. You've got to have it looking like that format. Okay. So what I'm going to need to do in order to do this part of the problem is I'm going to need to figure out the R, and I'm going to need to figure out the theta, plug them in, and be done. Okay. So I need to figure out R and theta.
Your brain's still here?
Well, what about the R?
I mean, it's 2.
It's 2. We've already done that, right? We don't need to do it again. And we've already said that R and the magnitude are the same thing. So we already know that the R is 2, right? So we're halfway there. Okay. Now, tell me how I'm gonna find the theta. How have we done it in the past?
Get our first angle off the point.
How did we find theta before? When we had the x and the y, which is essentially what we've got the x and the y, how do we use those to find theta? Yes, so we said tangent theta was y over x, right? That's our formula that we used from 5-1. So let's plug it in. The y is -1. And x is the square root of 3. So when I rationalize that,
Negative square root of 3 over 3.
negative square root of 3 over 3.
So that is pi over 6. But it's a negative. So then we have to do something to the graph.
Okay, it is a pi over 6 rotation, right? Okay. It's negative in the second and the fourth quadrant.
Right.
How do I know if I want the second quadrant angle or the fourth quadrant angle?
From the first
From the
graph.
first graph, okay? Where's your point? Your point is in the fourth quadrant.
It's G.
So you need the fourth quadrant angle so that it matches up. Okay, so pi over 6.
Negative pi over 6.
Okay, let's come around. So it's pi over 6, it's 5 pi over 6, it's 7 pi over 6,
11.
it's 11 pi over 6.
Now, with that being said,
Hang on, Sarah. If they do make the stipulation that you give a positive angle and that you give an angle within one rotation of the circle, okay? So they really do not want you to come in here and say negative pi over 6. Okay, that's part of the definition is saying that the angle that you're gonna give is positive and that it's not past 2 pi, it's just in the first rotation of the
Why ain't 5 pi over 6?
5 pi over 6 would be your angle in the second quadrant. But remember where your point is. Okay, so you gotta pull an angle that's gonna give you the same point.
that's what I was gonna ask. So we do not go
You
back.
don't wanna go negative with it.
Okay.
Okay, you wanna roll around, go positive directions until you get to where you wanna be.
Okay, so that negative is gonna determine which quadrant, like,
Yes.
okay. That's what I was gonna ask her. I would've went,
You would've gone this
Yes.
way and given me negative pi over 6. That's
Yeah.
it's just outside of the definition. I mean, it's not necessarily wrong, it's just the definition says don't do that. It says keep your angle positive.
okay.
So go the other way.
So it's like the little, what, the pi greater
Let
than,
me finish right quick here. So the last thing you wanna do is get this thing written in the right form. Okay, and that's your answer right there. Okay, so remember that once you find the R in the theta, to go back and sort of plug it into that format. Yes, what?
We don't need to solve it, cosine of negative 5 over 6 is the reference angle, we don't need to.
If you solve it, and we'll talk about this next time, but if you solve it, you go back to this. It simplifies back to what you had to start with, so you basically make yourself a big circle.
so we should leave it.
Leave it right there.